All right, welcome to the homework help for Unit 4, Lesson 2, Elvira's equation. Or maybe it's Elvira's, but that is not important. Let's jump right into it. So, for the ready, first portion, fill in the blanks for the statements to explain the process for solving as indicated. All right, so solve for x, where the equation is ax equals 7. I can find x, or 1x, by dividing by a, right? We're going to divide by a on both sides of the equation, right? Because if we have ax equals 7 and we divide both sides by a, we'll just be left with x equals something. So that's how we would do that first one. Solve for p. 8 plus p equals w. I can find p by, well, we currently have 8 plus p on the left side. So what do we have to take away from the left side and the right side to make it so it's just p equals something? We would subtract or minus the 8, right? Since the 8 is being added to p, so we have to subtract the 8 from p. Okay, so minus 8. Solve for m. E equals mc squared. Okay, so we can find m. So this is E equals m times c squared. So to find just the m by itself, we would divide by c squared, right? Whatever c squared is, we just have to divide it on both sides, and we'll just be left with m. Also, E equals mc squared. That's a famous equation. If you know what it is, maybe write that on your paper too, because that's kind of cool. It's kind of cool, but we won't talk about it right now. All right, we're skipping 4, skipping 5, 6. Here we go. All right, solve for y. Ooh, this is an interesting one. We've got a fraction. Solve for y. 1/2 y equals k. I can find y by, well, it's 1/2 times y. So if it's times, then we would say, oh, we have to divide by something. So we could do that. We could divide by 1/2, right? Divide by 1/2. That would succeed, right? That would work. Or, right, the same as dividing by 1/2 is multiplying by 2. Right? So either one of these would work. We could either divide both sides by 1/2 or multiply by 2. Those are actually the same thing. And then 7, solve for x. Y equals mx plus b. Our slope-intercept form. Perfect. We can solve, or we can find x by, we're actually going to need 2 steps here. This is 2 steps. This is the hardest one on this list, I think. First step is going to be subtracting b, right, by minus b from both sides. And then, right, and then dividing by m. All right, so that's how we would do it, right? We'd subtract the b from both sides, then divide m both sides, and we'd be left with just the x on one side. All right. Second portion. Jackson likes to be organized, so he made the following chart. He has decided to keep track of the miles he runs and the time he spends running. He attends PE class on Mondays, Wednesdays, and I think it's going to say Fridays, right? But let's see. Things of note here. He made a chart. He kept track of the miles he runs. All right, so he's keeping track of miles he runs and time he spends running. Okay. All right, let's go look. He attends PE classes on Mondays, Wednesdays, and Fridays, but he goes to school every day. Okay, so he goes to school. Let's assume that's Monday, Tuesday, Wednesday, Thursday, Friday, that he doesn't go on the weekends. We'll assume that. So he goes to school every weekday. All right, fill in the units column on the chart. Okay. So units are just what is being counted or measured. So on our first our symbol is M, and that's the number of miles ran in PE class on Mondays. So that's the number of miles. All right, so number of miles. So we're going to write down miles over here. All right, then the W stands for the number of miles ran in PE class on Wednesday. So this is also, right, we're counting miles, number of miles. All right, F is the number of miles ran in PE class on Fridays. Okay, so the M, the W, the F stand for Monday, Wednesday, and Friday, and the capital letters, right, this is all number of miles. All right, so these all have the same units. S, the number of miles from Jackson's house to the school. All right, so again, number of miles, but now we're worried about the school. So that's where the S comes from. So this is still measuring miles, right? That's still our units. But we are now measuring that's sort of like driving distance, or maybe it's a school bus, or maybe he walks, maybe he runs to school as well, but we don't know. H is the time in hours. All right, so it's telling us we're measuring time in hours. All right, so in hours. So what we are using here is hours. That's our unit. It's a unit of time. Then T with a little m. So we would call the m a subscript in this case, right? So it's a lowercase t with a tiny little m to the right of it. So we call that a subscript. So this is like the way I'd read this usually is T sub m, right? So T sub m, time in minutes, right? So it's in minutes, spent running in PE on Monday. Okay, so time spent running in PE class on Monday. So it's the time in minutes. So we're measuring this, right? The unit here is minutes. All right, this is also time in minutes. So T sub W is time in minutes spent running in PE on Wednesday. And finally, T sub F is the time in minutes spent running in PE on Friday. All right, so it's time in minutes again. All right, time in minutes. Excellent. So we've got our table filled out. Now what does it say to do after this? Using the table from question 8, make meaning of the expressions below. Write what the expression means. If an expression does not make sense, say why. All right, so we're making sense of an expression, writing what it means, and if it doesn't make any sense, we say why. All right, so M plus W plus F, all big letters, right, all caps. MWF is the number of miles ran in PE class on Monday plus the number of miles ran in PE class on Wednesdays plus the number of miles ran in PE class on Fridays. All right, so this is, this expression would be the total, this would be the total miles run in PE class, because he goes to PE on Mondays, Wednesdays, and Fridays. So that's all of his PE classes, and we're adding all of the miles together. So it's the total miles run in PE class. In PE class. All right. What is number 10? It's on the next page. Let's go look. 4 times M plus W plus F. All right, so we said that M plus W plus F was the total miles run in PE class. Now, 4 times that. All right, so if he ran, let's say, like 30 miles, this would be 4 times 30, which would be 120. So what happens, like what would happen every 4 times a mile is run? Well, if he's running on a track, then he has to do 4 laps in order to complete a mile. So if this is 4 times the number of miles, then this is actually the total laps, right? The total laps run in PE class. Run in, and I'm just going to say run in PE. That's fine. All right, M plus H. What is M? M is the number of miles ran in PE class on Mondays. Okay. And H is the time in hours he spent traveling to school. So M is measured in miles and H is measured in hours. So we can't really add those together. It would be like saying it would be like adding your age to your height, right? Which doesn't really make sense. Like you can't be, like if somebody asks you how old you are, you have to answer with like years and months and days. You can't answer with like, how old are you? I'm 6 feet tall, or something like that, right? That wouldn't make any sense. So M plus H does not make sense. Doesn't make sense. doesn't make sense. Because you can't add miles and hours. Can't add miles and hours. Okay. Here we go. That was 10 and 11. Now we're on to 13. All right, create an expression. Ooh, so create an expression. It says expression, not equation, which means we shouldn't have an equal sign in here anywhere. So expression, right, that's actually like what we've been looking at, right? Like these things up here, there's no equal sign here. It's just like multiplication and addition and parentheses, right? It's operations, but no equation, like no equal sign. So here we go. Create an expression based on the table, an expression based on the table from question 8 for the quantity that is described. All right, so the average amount of time running per day. All right, time running. So the time he spends running is T sub M, T sub W, and T sub F. So the average time running, right, the way we find an average is we add up the total number of things and divide by, right, we add up the total of each thing and then we divide by the number of things. So the average amount of time running per day, we're going to zoom in a little bit, should be T sub, oh, we shouldn't start with W, right? Monday's first. T sub M, which is the time spent on Monday, plus T sub W, which is the time spent on Wednesday, plus T sub F, the time spent on Friday. And now it says per day. Well, we might think, oh, there's 3 items, so we should just add those together. So if we had divided by 3, that would work. This is the average amount of time he spends running per day that he has PE. So that could be seen as a correct answer. Or, right, it had this note. Let's go back and check. Right, it had this note up here. Right, this last sentence from the information, right, he goes to school every day. And we said that this was Monday through Friday, right? So we're going to assume that this is Monday through Friday, which is 5 days. Oh, Monday to Friday, which is 5 days. All right, so we could also say that the average amount of time running is just how much he runs total during the week, which is the time on Monday, the time on Wednesday, the time on Friday. But it's per day, and there are 5 days, right? So maybe there's 5 days. So we could also justify making this TM plus TW plus TF divided by 5, or even divided by 7, right? Maybe you want to include the weekends as well, because those are also days. It's not really clear. So for 13, if you had TM plus TW plus TF divided by 3 or 5 or 7, as long as you could explain your answer, that would be correct. So let's go down and look at 15. Miles round trip from Jackson's house to school and back. All right, so round trip to school and back. All right, so that means however far it is from Jackson's house to school, we're going to do that amount and then add the same distance, right? Because to go someplace and to go back are going to be the same distance. So what is the symbol that's used for the distance between Jackson's house and school? Number of miles from Jackson's house to the school is S. Okay, so S is the number of miles. So I think here we're going to have 2S, right? Because if, oh, that didn't write. That's not a 2. There we go. So if we have just S, that would be the miles from Jackson's house to school, but 2 of those would be round trip from Jackson's house to school and back. So we could have 2s, or you might write, oh, well, we have s on the way to school and, or plus, s on the way back. These are actually exactly the same as each other, so you can write either one. These are the same correct answer, just one's written with multiplication, one's written with addition. But those are both correct. I would prefer to see 2s because it's multiplication is more condensed than our addition, but either are correct. All right, let's move on to the go portion. All right, last one. And oh, what was the instruction? The go. Find the domain and range for each function graphed below. Use interval notation. Ooh, okay, so interval notation. Let's zoom in real quick. Remembering interval notation is either, right, like this, right, where this is our low and this is our high, right? Or it's like this with low and high, or it's some combination of the two, right? We could have like this, right? This would be something, and we could also have this, right? And these all mean different things, right? The first one here means that the low and the high are included. The one here with parentheses means the low and the high are excluded, right? This one means that the low is included but the high is excluded, and this one means that the low is excluded but the high is included, right? So all of them are slightly different, but we're going to use some combination of the brackets, the square brackets, plus parentheses. So let's go look for domain and range. We are only doing 17 here. All right, let's see, 17. All right, let's do domain first. We'll do domain in green. All right, domain is our left, right? So the domain, we're looking at this point here and this point here. So what are these values that we're looking at? It looks like it's not included, right? This is going to be the low and this is going to be the high. So our low value, it looks like that is, well, if this is -5, -6, -7, it looks like -8 to me, right? This looks like -8. Right, so our domain is not included, so with parentheses, -8. And then what is the high value? It looks like this is, if we keep going up, it looks like that is 9. I think that's 9. All right, so from -8 to 9, and that is included, right? Because that's a filled in circle, so that is included. And now we'll switch colors. Let's do our range. Our range is going to be, it looks like this is the lowest point on the whole thing. And it looks like this is the highest point on the whole thing. It's right there. All right, so how high and low are these? Well, this is the low, right? And that looks to be 1, 2, 3, 4 down. So that's -4. Oh, lights went off on me. Hang on. Come on, turn back on. Thank you. All right. -4 is that's our low, is right there, and it looks like that is not included. So we're gonna have -4 in parentheses, and then there we go. And then what is our high? Our high appears to be, it looks like +4 actually, right? 1, 2, 3, 4. Yep, that line looks to be right around +4. So we're going to put +4 here. And that is included, right? Because that line is filled in, that curve is filled in. So we're going to have -4 to 4, like that. All right, let's keep looking to see if there is more to do. There is. There's another type of problem. For each of the inequalities, graph the values being described on the numbered lines. Okay, so right off the bat, we just have a number line with no numbers on it. So that's a little bit interesting. We'll do this one in green. Actually, maybe we'll do the actual values, or we'll do the tick marks on the line in purple, but we'll do the actual part that's filled in green. How about that? So x is less than 6. So let's put a 0, right? Just to be clear, we're going to put a 0 here. And then it looks like we need to have a 6. And let's put a -6 as well, just to be sort of symmetrical with it. All right. So here are numbers, and now we want to graph the values being described on the number lines. Okay, so if that's 6 and -6 and 0, right, we've got those shown. X is less than 6, so we need to be, it says less than but not equal to, so we're going to put an open circle right on the 6, right? Open circle here. And then less than 6 means we have to go to the left, right? Because 0 is less than 6, so 0 should be on it. -6 is less than 6. So it's going to be everything this way. All right, so that's our first one done. And then number 22, -7 is less than or equal to, oh boy, this is going to be, this will be a good one. -7, so we need the number -7 on here somewhere. Let's put that there. -7 is less than or equal to x, which is less than 0. All right, so let's put our 0 on here. We like putting 0 on. And then let's also put, we'll just put a +7 as well, just to be sure. All right, -7 is less than or equal to x. All right, so less than or equal to means we get a filled in circle. Filled in circle. So -7 is less than or equal to x, and then 0 gets an empty circle, and then it can just be anything in between those 2 points, right? So there we go. That is a graph of the values that are greater than or equal to -7 and less than 0. And do we have anything else? That is 22, and this is the last page. So that wraps up Unit 4, Lesson 2 for this homework.